So now we are here for the soft matter simulator. The first thing we want to do is in this sample tab, and we want to select the samples. So you can use up to 5 samples to just check the difference between them. So here for the starter, we just use sample 1. So in this sample tab, you have different samples. Those are from models that can be chosen from. For example, I choose this Parasol B, which is a very simple Parasol model, and you can change the other parameters for this sample, such as density, molecular weight, and also the concentration, and also the buffers. So here, the calculation actually already provide a lot of scattering curve here. So let's say we use sample 2. Sample 2 is the sample I choose here as a cylinder model, and with different radius and length. And as you can see, the I versus Q curve is changing. And once you set up the sample, you can go back to this Q setup, which is the instrument setup. And you can use different instrument setup up to 4 instrument setup simultaneously. Most of experiment on biosense, you will need only 1 Q setup or at most 2 Q setup cover the maximum Q range we can reach. Because we have 2 detectors, it's very convenient actually for us to get a whole Q range within 1 shot with 2 detectors. But here for demonstration, I'm choosing 2 Q setups. 1 Q setup is for the very lowest Q we can reach with 18 angstrom neutron here. So that is 18 angstrom. And the second configuration is a typical neutron wavelength. We're using 6 angstrom. So basically those 2 configurations, or you can use 6 angstrom neutrons with very close detector to sample distance. That can cover the maximum Q range we can get. So once you choose this setup, Q setup, you can look at how the scattering curve, the simulated scattering curve looks like at different Q setup. So for example, at this higher Q range, and we do the simulation on the sample 2, that will calculate, and while it's calculating, you can see this on the status update, it says simulation in progress is green. And now the simulation is done, and you can look at how the scattering pattern looks like. See, because this sample 2 has orientation here, and it's generated long isotropic scattering pattern on the detectors.